Hello children, today last class we had done with the Huygens principle, right? And in the Huygens principle we have seen how the propagation of the light waves, the waves are taking place in terms of the wavefront. And we had seen the different types of wavefronts also, the spherical, the plane, and then the cylindrical. But in today's class we will be doing two important phenomena which you have already understood or learnt in your class 9 or 10 optics chapter, but in this case we will be doing it based on Huygens principle. Now that is the reflection and the refraction. Now let us do the first one. We are doing for the reflection, okay, that is from the Huygens principle. Reflection we are doing with the phenomena reflection of a plane surface based on Huygens principle. It is being based on Huygens principle. Okay. Now for this, what we really need, we need a plane surface. This is your plane surface which you have considered. We need a wavefront also. This is the wavefront that we will be considering. AB is the wavefront. This is the incident wavefront, what we call. Okay. And this is the angle of incidence for this. And the rays which is normal to it, these are the rays which are normal to it. These are the rays. These are the incident rays. Okay. Now, what you find that when you look at this wave, this is the ray. Now, in this case, if I take this as the normal, then this is angle of incidence for this ray, and this will be angle of reflection. Okay. Now, taking the time during which this ray, this is the first ray, this is the second ray, the time during which this falls on the surface and gets reflected. Okay, so we take this as the we take as defined by Huygens, we take this as the center, and taking the velocity of light and time as the radius, what we find that we will draw an arc, that is we are drawing a circle. Okay, by the time it comes from this place to it just starts from here and just reaches this place we have taken as B dash. That time this rays fall from here to this particular point. Let us assume it is falling at this point we have taken as A dash. So if we draw a tangent and connect it, this becomes what? This becomes a reflected wavefront. So this is R. So this becomes your incident wavefront and this is your reflected wavefront. How we have got, I have already explained. Because taking A as the center and AB dash as the radius, you have drawn an arc. So what we find at, and that time only this ray falls from here. So what we can infer, the medium is same, that AB dash is equals to BA dash is equals to VT, because they have the same distance, right? Now if we look into the triangle, if we get to see the triangle, in triangle AB A dash, this means we are talking about this triangle. So this is angle, so this is perpendicular and this becomes hypotenuse, right? So sine I will be equals to perpendicular, so it is BA dash divided by AA dash. And in triangle A B dash A dash, what we get, sine R, we are talking about this triangle, so this is the perpendicular and this becomes hypotenuse, so we get AB dash divided by AA dash. Okay, now if you take this as equation 1 and equation 2, if you divide this equation, sine I by sine R, BA dash by AA dash, AA dash divided by AB dash. So this gone and this is also same, this is also gone, because these are equal, right? So we get sine I by sine R is equals to 1, this is equals to 1, or sine R, or we can perfectly write I is equals to R. This shows that angle of incidence is equals to angle of reflection. So we have proved that. And further, if you get to see the lines, then the incident wavefront, the reflected wavefront, they lie on the same plane. So we have proved the first law as well as the second law, that is the uh, angle of incidence is equals to angle of reflection, and this has been done by the Huygens principle. Hope you have understood this. Thank you for watching. This is very simple, and try to understand, try to get, so you understand well on this. Okay, thank you.